Hello everybody. So today I will talk about the system design of LeetCode. So I will do the deep dives. So today's topic is number one, fairness and security of the code execution. So this non-functional requirement. And also I will talk about the scalability, this non-functional requirement. Okay, that being said, I will start with the first one. Okay, so fairness and security of code execution. So this is the code is currently executed with execution worker. So user submits the code and submission service creates the submission record and we change the capture, which is encoded into the Kafka. Now execution worker subscribes the Kafka and know which submission record was created. And then literally this execution worker executes the code in this server and then update the result columns. So that's the current flow. But I decided to make a change on this because change data capture is used for the kind of data synchronization, not for the trigger of the execution code execution. And the code execution is the most important feature of the LeetCode system. So it's not a good idea to use the change data capture here. So instead of this, I will make a error update. So when submission service is created, when submission is made, submission service creates the submission data in the submission. This is the same. And this, because the code is not executed yet, the result columns are not filled in. And after this creates the submission record, it also encodes the data into the Kafka. So now the code, I can say the code is written here, recorded here as the submission record. So Kafka message just have to have the submission ID. Submission ID is enough because after execution worker fetches the record, it reads the submission record again. So this subscribes and read it, then execute it, and then updates the result. So this is the basic, flow. So I actually suggested this approach in maybe 2 days ago, but I didn't use it because of the data inconsistency between the submission DB and Kafka. So let's say it succeeds to submit the record, creates a submission record in the submissions table, but let's say writing the message into Kafka fails. In that case, that submission is not executed. So but as I said, introducing the change data capture is not a good idea, so I will go with this. Actually, there is a kind of approach which is named transactional outbox pattern to write for the dual write. So it's like creating the outbox table here in submission and create submission record and outbox record in the same transaction atomically. Then outbox record is scanned by another worker and that worker executes the submitted code. But this is also kind of complex architecture. So the approach I will take is, firstly, it pushes the record into Kafka. So let's say write, or I should say publish. Then um, it creates the submission record. So this order is very important. I will tell you. So then this is read and this is done. So in this case, let's say writing into Kafka succeeds, but creating the submission DB fails. In that case, the server side can return the failure to as the submission API response. So the client treats the submission as submission failed. So internally, execution worker still reads the that submission record. But what happens is okay, sorry. So I will just quickly say submission ID is created in the submission service. So Kafka has a submission ID message. Yeah. So execution worker knows subscribes the message in Kafka, and with that submission ID, it reads the submission DB. But if this create number to create it failed, the submission is not found. So with that, this execution worker gives up the execution, or I should say, it doesn't do the execution. Simply saying. So I think this is enough. So with this approach, I don't have to take care of the data inconsistency. And also I can say we don't have to change data capture or transactional outbox pattern. I think this is much better. Okay, so that being said, I will talk about the code fairness. So firstly, because I introduced Kafka, the fairness is already guaranteed because Kafka is obviously the first in, first out queue. So the firstly submitted code is executed by execution worker, which is great. So I've already met the fairness. And now I will talk about the security. So as I explained, it is possible that users submit the malicious code and these execution workers unintendedly, compromised. Yeah, so I want to avoid it. Okay, so what I can do is to execute the code in the Docker container. So the Docker container is a kind of virtualization of the server. So when the code is executed on the container, we can configure the kind of security, or I should say the separation query. So in that way, even if something like malicious is being intended, we can stop it, or I should say we can close it in the Docker container. So this execution worker boot out the sorry, container inside. So of course it depends on the programming language. So let's say Python code should be executed. It needs a Python interpreter in the container. So we create the kind of virtual image of Python container and execute the code on the Python container. So that's what we can do. And okay, the thing is, yeah, I use the Python container. I will quickly tell why I don't use the virtual machine. So this is a kind of typical classic explanation, but the virtual machine kind of runs the OS, virtual OS, on the host OS. So it has to boot up the OS from OS layer in the virtual layer. So it is quite heavy, resource heavy, and also it takes time to boot up. But container is kind of very lightweighted because it doesn't, boot up the whole virtual OS. What it does is a kind of adjustment, or I should say adaptment. Adaptance of the different OSs. Yeah. So let's say I choose Ubuntu and it is running on the Mac OS. Then that container doesn't initiate, or I should say, run the Ubuntu OS, but instead it kind of does adaptance of from Mac OS to Ubuntu OS. So yeah, that's why Docker container is lightweighted, and I chose it. So that being said, when this execution worker, when this boot up the container and runs the code, what it does is, in the execution command of the Docker running, it would set the timestamp. Time limit, like 10 sec. Yeah. And also I can say memory usage limit. I can specify that. Of course, if we should, we can stop the execution if the memory limit exceeded. But just as the kind of secure safety net, I set the memory usage limit. And also this is same for time limit too. Internally in the container, we can stop the execution if it is, it goes beyond the time limit. But as a safety net, I set the time limit here. And also I would say, I will run the container with read-only mode. Yeah, because it doesn't need to read the code in the container. So I set it. And also no OS system call. So it obviously doesn't need the OS system call. So I also specified this when running the Docker container. Maybe one more thing I can set is no network call. Yeah, connection. Yeah. Yeah. Maybe I should clarify this. But the thing is, if I prohibit the system call, network call is not possible, obviously, because network connection, is, done with system call. But I just clarify here. Yeah. Okay. So these are something I can do to, guarantee the security of the code execution. Okay, so yeah. Okay, so I talked about the fairness and security of code execution. So I wanted to do this scalability, including the real-time ranking dashboard. Yeah, but obviously, as you can see, it's late at night and I have to go back to my job. So today I will finish with this. Yeah. Okay, that being said, thank you so much for watching. Yeah, have a good night. Bye.